So if you need to evaluate this using the half angle identities, we can use this one that refers to sine. But to make this happen, we need to put things in terms of x here. This is 5 pi over 12, which is the same thing as, it says sine 5 pi over 6 times 1/2. And I did that because dividing by 1/2, that's the same thing as multiplying by 1/2. And when you separate this, now it's clear to see what x is. X, in our case, is 5 pi over 6. So we'll be able to plug that into the formula to find out what sine is. So we said for our problem over here, x is going to be 5 pi over 6. So when we plug that in the formula, we got 1 minus cosine of that 5 pi over 6. It's all being divided by 1/2. So this is something we can solve. Let's set that aside. 5 pi over 6. The angle is a little less than 1 pi. 5 pi over 6 is less than 1 pi. So the angle looks something like that. And if it helps, put it in terms of degrees. 5 pi over 6. That's 150 degrees. So that makes our reference angle 30 degrees. And so when we draw our reference triangle, 30 degrees always corresponds with 1/2. And so that makes the other angle 60 degrees, which always corresponds with square root of 3 over 2. And so now we have everything to answer the cosine ratio here. That cosine of this reference angle is the adjacent divided by hypotenuse. And the hypotenuse in the unit circle is 1, or for this triangle for that matter. So adjacent divided by hypotenuse gives us square root of 3 over 2. But we'll also have to note that this is negative, because you can remember if you can remember the little memory aid, all students take calculus. That helps you tell whether your answer is going to be a negative or positive in whatever quadrant your triangle's in. All are positive here. Students means that just sine is positive here. So that means that our answer for cosine needs to be negative. So here we said the adjacent divided by hypotenuse is negative square root of 3 over 2. So I'm going to put a negative square root of 3 over 2 in here. So simplifying further, positive negative, we get square root of 1 minus the negative square root of 3 over 2. That's 1 plus a square root of 3 over 2, all being divided by 2. So you can break up the square roots as a square root of the top over the square root of the bottom, because everything is being square rooted. But then since we don't like having a square root in the denominator, we'll rationalize it, and we'll simplify the top all in one step here. So here's the last step we were on when we simplified by taking a square root of the top and the bottom. So check out how I got from here to here. I factored out a 1 over square root of 2. Since it's in a square root, it can multiply back in, and that'd be 2 divided by a plain old 2 to make 1 here. This would be a square root of 3 divided by a plain old 2 to make square root of 3 over 2. So these two are equivalent because I factored out a square root. And when square root times a square root, they can communicate with each other. You can multiply it back in. So by factoring out that 1 out of square root of 2, that's the same thing as saying this. And we can multiply the denominators now to give us square root of 4. In other words, just a plain old 2. So there's our almost final answer. We just need to deal with this positive or negative symbol. And that's got to come back to what we started with here. We were doing sine 5 pi over 12. Sine pi over 2, which would be 6 pi over 12, is exactly a quarter of the way around the unit circle. It would be right here. So sine 5 pi over 12, that's right here. That's in the positive quadrant for sine. So any angle, any trig ratio that we make for sine in the first quadrant needs to be positive. So that's how we decide on that symbol. Is that this is going to be the positive of the answer. And that should be it. I think maybe the easiest part is actually using that half angle identity. From there, we plugged in values. We found out what cosine 5 pi over 6 was. It's negative square root of 3 over 2. And then we simplified, because we had minus and negative. We just said that's plus square root of 3 over 2. And then we broke it up into two separate radicals. We said it was square root of the top over the square root of the bottom. And so we said we can't have a square root in the bottom, and we also want to simplify the fraction in there. So that's where I did the tricky part of factoring out a 1 over square root of 2. Because if you were to multiply that back in, the square root and the square root, it'd be able to come back in terms of 2 over 2 plus square root of 3 over 2. So this is equivalent to what we had above. And then when you factor that out, you can write it as 1 over square root of 2 times everything, giving our bottom the positive 2 power there.